Okay. Good morning once again. So yesterday we discussed about the application of an embedded system, classification of embedded system based on complexity and performance. Now we have to go for the purpose of embedded system. So they have listed here six major purpose of embedded system, what it can do, right? So embedded system, it is for generally for an application with multiple peripherals added to that one, and you are collecting few of the information, and based on that information you are processing some data, right? So that is what everyone are doing now. They are giving name it as artificial intelligence or machine learning, right? So they are giving fuzzy type. So many words you might have related with this embedded system, but actually what it does is that normally it collects information, and that information it is going to be processed for a particular type. Suppose say Amazon, if I go, or if I go for Mintra option, if I go, right, all this portal where we are buying our goods, right? So it will search what I had searched, right? Not only that, if I take Facebook also, or if I take YouTube also, if I click ARM material or ARM videos, so it will search all the videos with the keyword ARM, and it will be displayed, right? So it is that way we are doing, and that is possible because there is a content present. Okay, the data is available, right? So that is why we will take the data collection, storage, representation. Then we do data communication. Then we have data processing or signal processing. Then we monitor the things. Then we control these things. And these all things will apply for a certain application. So individually we will be discussing all of this purpose of the embedded system. Okay. So data collection and storage. So you can give an example of a digital camera where your images will be stored, and or because that will be also limited, maybe 10 GB, maybe 16 GB, maybe 64 GB. So once it is filled, so again we need to copy to our desktop or a laptop. Again, then we need to uh, flash that memory. Then again we are going to use. So this is one simple example where data collection, storage, and representation. Your representation may be in a bit file, right, or a text file, or a numbering file, or a video file, or a audio file. So these are the different data collection you can do, and based on your data you can manipulate your information. The term data refers to all kind of information. That is what I was speaking: text, voice, image, video, electrical signals, and other measurable quantities. Data can be either continuous or discrete. The collected data may be stored or transmitted, or it may be processed, or it may be deleted instantly after giving a meaningful representation. Right. So we have data communication. So we have a Wi-Fi spot, you have a dongle, you have a mobile phone, you have a setup box. So all it will be communicated using these technologies like Bluetooth, Zigbee, Wi-Fi, Edge, GPRS or wireline modulus, or different types of USB, TCP, IP, right, program status, different hubs, routers. So all these devices will be helpful in processing your data. My laptop also is been connected to mobile phone using a hotspot, right? So that in that way I'm going to transmit my data. My laptop is having a USB port. Yeah, I'm having a DVD port, right? I'm having a wireless LAN. I'm having a wired Ethernet connection. So there are different types of thing which has been presented for the transmission of your data. See, observe this. All these things are in a general. It is just like a explain type of a questions or a write a short notes type of a question. Okay. So in examination also they will be asking in that way. That is why that short attend assignment I had given for you to complete by today. Okay. So data signal processing. So you have earbud which will convert your signal processing means audio into the things. We have different types of processing part like for your different types of datas. Okay, so it can be a audio video codec, it can be a transmission application, it can be a speech coding, your microphone, your earphone, right? So it all converts your analog data to a digital data, or a digital data converting to an analog data, because that is also needed, right? Because low level language we cannot write, high level language it cannot understand, because it is not having any thinking capability, right? And we are not having to remember bits for duration, for long bits we cannot remember. That is why we have to follow these signal processing or data processing types, so that it will be very easy, right? Then monitoring. So example is taken with respect to the medical application. So continuously it should be monitored. In examination also, your camera they will be adjusted, so continuously it will be monitored. So if any distraction is there in the exam hall, so they will call it and they will check it, right? But majorly monitoring application, if I tell, it is with respect to the medical application. So medical application also you have device, so it will give all your heart rate, beat, pulse, everything, and it will tell that what is the status of that part, right? So these are the few examples which I have given for your embedded system, and this is with respect to monitoring your data, what it has been accumulated, right? Now what happens, now if I go, or anyone has visited recently to any hospital, now there is no file kind of a thing, so they will take your name, your date of birth, your mobile number, and all your records will be stored into that memory, right? And whatever track it is there, you can easily track when you have visited last time, what was the status, what is the report. So now no need for you or for us to carry any of the paper. If you go to the some high end hospitals like Columbia Asia, if you go, so you will find all these information. Rama Hospital, if you go also, they will also maintain in the software. Now everything it is linked to your mobile phone. So if you give your mobile phone, they will track what are the history, right? Now it is nobody will carry a file, right? So that is the information you can see, and whatever information doctor want to give, he will put into that message, it will go and sit into that portal, and user, the person should go to the desk and collect his prescription and all those stuff, if a hard copy is required. Otherwise soft copy only it will take. Now billing section also it is of that kind. If you go to Apollo pharmacy or you go for MedPlus pharmacy, they are not going to give any receipt to you, right? Still you ask receipt, they are going to provide you, but before you, after you pay, immediately one message will come to you that your receipt has been generated for so and so, and you can download your receipt, right? So these are the few things which you can see. So another 1 or 2 year or 3 year down the line, you can completely revise the things. So your admission order, everything, every document, it will be stored into the memory, right? So who is monitoring that one, who is having the access, those all it becomes a question mark, because still it has been not finalized. These are the few things which has been present for different types of application, right? So app also you take, every session it is recorded. For how many days it is recorded? For 29 days it will be recording. After 29 days it will be erased. That is a problem which is there in this too, right? Purpose of embedded system is to control. So controlling operation, it is with respect to this air conditioner which I have given as an example. So air conditioner, now you see that when I switch on my air condition, so I am setting for a particular temperature, but that particular temperature for longer duration of time, if it is there, it is not suitable for us. So what we will do, we will change it. So now air conditioner, how it is been present, so based on the room temperature, your condition, everything it will be automated. So first it was 10 or 15 degree if you had set, so later if the temperature has come down, so it will reduce it to or increase your temperature. So automatically we are going to do, right? So channels also you can set in the television. So you are going to set my favorite channel, suppose say cricket match if it is there, So 9 o'clock it is scheduled. So if I plan or if I schedule for 9 o'clock, so whatever channel is there, it will stop and it will directly go into that particular 9 o'clock channel. The cricket match which I have said, it will be on. So calendar event also it is like that. So it will tell that so this meeting is been on, right? So these are all the application where we can control, which will be very helpful. Means what we will forget, and these device will help us to intimate that this is going on or this activity is going on. So temperature is high or clothes have been means all the clothes have been washed. So you can open your door and all those stuff. It will be giving information. So these are few examples of what you can do with your data, right? That is the importance of this embedded system. Earlier every time we have to do, right? But now it is what nobody is required. It can only happen based on what data it is there. It will process, and how it will process it is with respect to the experience it will have. So initially when there is no inputs, so it is difficult what to be processed. And when you know what process it is going to on, so it will be doing on its own. It is not intelligence they are using, it is a process which is going to be happening over there. So now every time I would put a message and would have intimated to you. Now what I am not putting a message, I am intimating you that you need to log in through that one. Next time onwards, what you have to do is that no need of intimating. So every week schedule will be there, timetable will be there. So you only will log in. But you people, we need to tell you because you are not so much. Means you are not all of you. Few people we need to intimate because they will forget it, right? And few people will join only because of attendance. That is a different issue. We cannot uh, add it over there. So I'm just telling to you how you can control your information or your data in this embedded system and what is its results. You can observe it. That is a thing which is present. Application specific user interface. So he has taken a mobile phone as an example where you have all these things like keypad, LCD display, system speaker, vibration alert. So these are all everything present like switches, keypad, lights, bells, display units, etc. So one application I can take is for the mobile phone. Right? From mobile phone I can control my television. From mobile phone I can control my home automation. Is it or no? So I will be knowing that tube lights or lights and fans have been on. So no need for me to physically be present there to turn off. Okay. If I'm in the college, so from my mobile phone only I can turn off. That is why they call it as a home automation. Right. Now still it is not completely existence. So another 5 years, so everyone will be shifting to this home automation system. Now in the movies also you might have observed that when you enter the room, then only your lights will be on, and when you exit, lights will be off. Right. So that is a thing which has been present. Over 5 years down the line, it will be applicable. Every home it will be there because now it is new. The cost will be very high. Over a period of time, the cost also it will be reduced. So everyone will be utilizing. Earlier, web camera was not there, right? For you, security cameras. You rarely find security cameras. Only near the banking system you will find that cameras. Now every street, every apartment or every what you call villas, you have this smart cameras present. Security cameras which will be very helpful. Means I'm telling you that how we are changing. What it was earlier and what it is now, it is completely drastic. Still many of things we have not observed. For a period of time we will be observing that also. Okay. So these are all the purposes of the embedded system. Now what is embedded system? What is a how you observe a typical embedded system that is been given here. So in an embedded system you will be observing a processor, a system core. This system core can be a FPGA, application specific integrated IC, digital signal processing, or system on chip, or a microprocessor or a microcontroller. And for this thing, you are adding a memory, you are adding a software, you are having a communication interface, you are having a input ports, keypad, or it can be a sensor. Okay, sensor what we are discussing now, and it can be an output port, which is nothing but your actuators, right? And there will be some other supporting integrated circuits and some system, and complete these typical embedded system we call, these are the major components, or we call it as a elements of embedded system. In examination one question also it is asked, explain the elements of embedded system for 8 marks. Okay, so these are the things which you need to explain one by one. So typical embedded system, it contains a single chip controller which acts as a master brain of the system. So FPGA kit we were using master and slave communication. So here also we are having master and slave communication. Your master will be your processor and slaves will be your peripherals which have been added. So your controller can be a processor, controller, FPGA, DSP, or application specific integrated IC, or application specific standard product, ASSP. So these are the elements which is present with respect to the controller. So an embedded system can be viewed as a reactive system. So there are two types of systems which will be there. One is proactive, one is reactive. Proactive means it will decide everything priorly, right? So what operation should be done, everything. Reactive operation is what? It will react based on what input you give. Okay, that is a thing which will be present. So your embedded system is a reactive between system. Why it is reactive system? Because you are giving input, based on your input it will react. The control is achieved by processing the information coming from the sensors and user interface, and controllers controlling some actuators that regulate the physical variables. So you can understand that what it is happening. So sensor, it will sense, it will give the input, it will catch, it will process, it will give the output. That output will be displayed or it will be sent as a message. So these are the things which are present. So common interface are keyboards, push button, and all those things. And common outputs are LEDs, displays, buzzers are the example for the output devices. So typical embedded system, again it is with respect to the memory. So n number of times we have spoken with respect to a memory. So read only memory, PROM memory, random access memory, static RAM, dynamic RAM. So n number of things which are present. Volatile memory, non-volatile memory, right? Cache memory, right? Temporary memory, permanent memory. So there are different names having specification for that particular type, and which is suitable for you. You can take that as a memory part into your embedded system, right? Communication interface, as I said, there is a Wi-Fi, infrared, Bluetooth, there is a UART communication, serial peripheral communication, I2C, you have a JTAG, you have a Ethernet U45, right? RJ45 we have. So n number of cables we have which will connect our device. Maybe a wired type of a communication, or we have a wireless type of a communication. Okay. Then what is a core of an embedded system? So core of an embedded system contains a processor, controller, memory, memory controller, core of an embedded system. So whether it is Intel 5, Intel 7, so that which generation it is, so that is important to me, right? Not that I'm having 1 TB of the space, I'm having 15-inch screen or a 17-inch screen. It is a lightweight, it is having so much of RAM. So those all things doesn't matter to me. I want what is a processor, because if that processor is there, functioning fast, everything I can observe. Other things it is very difficult for me to do the things, right? So core of an embedded system, by default it is your processor. See, almost 80% of the embedded system are processor controlled, or processor based, or a controller based. So most of the system in the industry and monitoring application using common available microprocessor. So you can just read out the things which has been present here. General purpose and domain specific processor. So what is a processor? So n number of times we have discussed this. What is processor and what is a microcontroller? So there is a difference between general purpose processor application specific processor. So you can read this differences. It will be available in the material which I have already uploaded in the Teams. Okay. Discussing about microcontroller. So a little bit different between processor and microcontroller is a bit size, the space, internal memory, external memory. Those are the things which has been present. I think again you have a comparison here. So comparison for the microprocessor and a microcontroller you can observe here. I think we have already discussed this comparison: microprocessor, microcontroller, von Neumann Harvard architecture, CISC and RISC. So in the notes it was there. So now it is given in the PPT. That is the only difference you can observe here. Right. So DSP processor. So DSP processor you cannot daily use in your homes or to your colleges, right? So processing DSP is signaling, it is for with respect to some signals, and those application you can find in the laboratories or in the research, right? So these are the few present, because you are doing n number of convolution, you are doing, right, you are converting your data, right? So their application, they are using this digital signal processing toolbox. So one example for this one will be your MATLAB. So in the MATLAB you are going to have a communication toolbox, image processing toolbox, VLSI toolbox, right, microcontroller toolbox. So if I install all those things, you can run your processor and you can simulate your data and you can check it. So that is why I have taken this MATLAB. MATLAB, it is done for you. It was there earlier.
Yes, sir.
Previous semester, right? Fourth semester. Fourth or fifth?
Fifth sem, sir.
Uh, which communication tool set you have used? You are not remembering. See, one communication tool set box you will be using. Maybe I think you are using the signal processing toolbox. Right, that is why you search in the toolbox, different toolbox of MATLAB, you will get different, and for each you need to purchase. MATLAB also we purchased for 2 lakh something for only 10 licensing, and for only 2 toolbox we have purchased, not all the toolbox. Again, it depends what type of domain you are in, so that particular toolbox you need to purchase. Okay, so these are the examples of DSPs present. So again here you require program memory, data memory, computational engine, IO unit. So all it is there. So how a controller will be there, for the processor also it will be of same kind. So then he has given a comparison between a reduced instruction set and complex instruction set. So reduced you will be having few instruction, complex it will be having lesser, but it will do more. So you can see the instruction set contains only 32 instruction in reduced set, but complex it contains 255 instruction for 8051 microcontroller. Right. So again we will find a comparison chart between a RISC and CISC. Okay. So I think this also we have discussed. So we'll just go on with further. So Harvard and von Neumann processor. So von Neumann architecture and hardware architecture. So we have a comparison here. You can refer the material notes or you can refer the PPT for answering this question. Okay. Based on the number of marks you need to do it. So you can see everything, it is inbuilt, and here it is separate. That is a major thing we will tell. Okay. Within the processor you have all the information, because we will tell that in your processor also there will be some memory, and you can have some external memory, and you can have some memory protection unit, so that you can still store your data. That is a difference you can find. So comparatively high cost, comparatively cheaper, no memory alignment problems, allows self-modifying codes. So all the since data memory and program memory are stored physically in different location, no changes of accidental corruption of program memory. So here it is having a single memory, so you will face lot more problem, not lot more problem, but you will feel little bit difficult because it will become complex because it needs to identify data bus and instruction bus. That is the thing which has been present here. So now comes your big Indian and little Indian processor or controller. I think many of you have written this one. It supports big Indian, it supports little Indian, which I have written. But what is this big Indian and little Indian is that how you are storing your data into the memory, right? So if I give first data, whether it will stored in a higher nibble or it will stored in a lower nibble. So it is with respect to the memory which is going to speak. So Indian NES specifies the order in which the data is stored in the memory by processor operation in a multi-byte system. So why it is? Because you have memories and you can read data like this or you can read data like this, right? You can store data in this way or you can store data in this way. There is no problem, right? Whichever way you want, you can access, and based on that only these two things have been evolved. So he is given with an example. Suppose a word length is of 2 byte, then data can be stored in memory in two different types: higher order of the data byte at the higher memory, right, like this, and lower data of byte at location just below that memory, so like this. So this is higher nibble, this is lower nibble, and this we call it as a little Indian. Okay. Now if again I am having a memory, lower of the data in the higher memory and higher the order of the data in the lower memory, so this we call it as a big Indian process. Now what is the example of this one? So yesterday, not yesterday, day before yesterday, Monday's batch, in the lab I have shown that there was in the lab tool like this, a window was there. So here all your register were present. So here you have written your program and output, right? And here there was a memory. So if I select this location and I was seeing the output here, and this output was in a reverse order. Okay. So it was a reverse order. So here in this, I was observing what data I have given, and the same data it was in reverse. So what type of Indian it was following? It was following the big Indian data. Okay. You may be asking, sir, why it can be in a simple way? Why it can't read in this way? Why you want to change in this order? See, for one particular application, you may feel this is easy, right? But for the next application, so it will be very difficult for us to identify. What here he has taken only 2 bytes of data. Now if it is a 4 bytes of data, so how we are going to allocate here, how on what basis? So we have that issue, right? It is not only, I will tell to you, mark my words that in the lab exam they will ask what is the difference between big Indian and little Indian. So they will tell, sir, higher order will store in higher, lower order will store in lower. That is called little Indian. A lower order will store in higher order, higher memory, higher order or higher order will be stored in a lower memory. That is big Indian. That is fine. You are telling what is its function. But why it is stored in that way? What is the use of that one? So you have to take one example and you have to tell, sir, if I take application like this, so this is a issue which will happen. Now let's take example of a multiplication. So I am doing x1 x1 x2 multiplied by y1 and y2. So when I do this one, y2 is multiplied by x2, y2 is multiplied by x1. So I am storing here. So here this value I was matching because I need to sum here, right? So I want only this part. So this was difficult if I go for this little Indian. So that is why I will go for this big Indian where I can interchange the data. So still many more examples are there. We will be discussing about this big Indian and little Indian when I take up the memory part, and again it is with respect to the load and store instruction. Okay, so that part we will be discussing. Right. So you can observe here big Indian and little Indian. So little Indian address is given, so it will store from the higher order only. So byte 0, right, base address plus 0, right. Now 1 byte of address which is having a base address. So same data I want to store the next value. So byte 1 value I wanted to store, so address will be base address plus 1, right. So earlier also it was there, in the lab also I was saying the address was 120 and the next address was 124. This was for R0 and this was for R1. Okay, so it was having plus 4. So why is that plus 4? Because I am considering 32-bit of data. Okay, 32-bit of data. So it will shift to this location because R0 will be having 8-bit, 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 and this forms a 32-bit data, and this 32-bit data is used for that instruction LDR or a move instruction. So every time you observe that if it is 120, if it is a 32-bit data, it will be plus 4. So next register address will be 124. And that address you can see here. So it is going to follow this type. Sir, you said that it is going to follow big Indian, but you are telling that it is showing here. So what happens? This value, the higher nibble value, so it will be stored 1 point here, 1 part here. So higher nibble value it will be, so higher nibble, lower nibble, higher nibble and lower nibble. So when you observe the result, you will carefully be knowing that how it will be stored the data, right. So this is with respect to the calculation the address, right. So what is this address? Your base address plus 0. You may be heard about this effective address, physical address and the base address. Base address, it is for the instruction core which has been present. Okay, effective address is what? You are giving some location into that base address. It will check for that location address and base address plus effective. That address it will calculate and it will give the effective address. So all those things we no need to worry now. So just as of now, you can tell that if it is a 32-bit address, 4 byte of data I wanted to store. In a little Indian if I process, so I am going to get byte 0, byte 1, byte 2, byte 3, having a base address plus 0, base address plus 1, base address plus 2 and base address plus 3. Right. If it is in a reverse order, if it is for a big Indian 3210, this again it will be remaining same, right. So this is a difference which you can find in the big Indian and little Indian of the processor. So what type of instruction you are going to use? You are going to use the load and store instruction, right. So again same concept it is there here. So again it will take ALU, it will take this register, load R1 with X, load R2 with Y, add R3, R1, R2 and store your result R3 in Z. So simple operation you can see. So ALU take R1 data, R2 data, process R3, store the result in R3. Your R3 you are going to give in the location Z. So your result will be stored here, right, which is 23, and this can be stored into the location also. So R1 I will be storing in X, R2 value I am going to store here. So in this flowchart you can see here, so this is location, which is your memory, this is ALU, these are your registers. So source register operand 1, source register 2 and this is your destination. So S1, S2 I can write. So how to get this data? From the location from X. How to get this data? From Y. And you are giving to a ALU, arithmetic and logical operation. So you are doing add operation. So 00 plus 7F you are doing, and that result will be stored in R3 and R3 will be, it is loaded here and it is stored into this Z value. So for that only he has written this instruction, and it will follow execution in this order. Right. So first instruction, second instruction, third instruction, and the last storing part. This is one simple example which they had given to us. So again, you will be having to do this pipelining structure. So we have fetch, we have decode, we have execute. So first you are fetching the instruction load, and when it is executing already pipelined, so you are going to get processing the next. So your pipelining concept you are going to use, so it will reduce your speed. So speed will be increased, not reduced. Your result will be at a faster rate. Okay, so to do this one we have a concept of pipelining, right? Again I am telling it is just a general type, so that it will be very, that is why I am going little bit faster. Right. So during instruction time, what it will happen, how it will process, how it will take data. So all those things, load R1 X. So it will identify what is X. Load R1. So it will go and tell the data it will be stored. Okay. Then R2 Y. Then add. Then you will do this processes. Load the value R3. Then it will store the result in X location. So that is what he has explained here, right? So clock cycles he has taken and he has briefed. So you see that first instruction. So this is first instruction. This is second instruction. This is third instruction. So differences. So here it is executing the result is already fetched. So it is next line. So it will be pipeline. So it will be very easy. Right. So this is a part which has been present here. Then we have application specific programmable logic device. So this we will continue in the next class. Okay. All